Hi and welcome to this second video on SymPy. In this video, we are going to go through how to define symbols in SymPy. This is going to be a direct continuation of the previous video, so if you have not seen video 1, I suggest that you click up in the right corner, or down in the description you can find the entire playlist. So the topic of this lecture is going to be defining symbols, and symbols are typically denoted by X and Y, which appears in your mathematics. We are also going to learn how to factor and expand polynomials in SymPy. So as always, I import SymPy as SP, run this cell, and now we have imported SymPy. So what you can notice is that I did not go up here to press run. So the point is that Jupyter has several shortcuts, and to find the shortcuts, you can go up here to help, and then keyboard shortcuts. So for instance, if you want to run a cell and select the one below, you can press Shift-Enter. So let me close this window and continue. So I can press Shift-Enter to go down to the first cell. So let's start by actually making a symbol. So I'm going to make a symbol, which I call X, or has variable name X, and you do it by using SP and the symbol class. And the symbol class takes in a string, which is the name of the symbol. So in this case, I make a variable X with the symbol name X. So let me run this cell, and if I want to actually print out the X, I can run it like this. So in Jupyter Notebook, this will be printed with a slightly different font than a standard variable. Okay, so now we have a variable named X. So let's try to do something with it so we can make a simple expression. For instance, 2x plus 5 in SymPy. So then we take 2 times x plus 5, and let us just return it. And it seems like it understands what we mean. We get out 2x plus 5. So one thing is that this name here and this name here do not need to coincide. So if you want an extra challenge in reading your code, you can have a variable x, which corresponds to a variable y. So let's just see an example of this. So I give it the variable name y, and I want it to correspond to symbol set, and run this. And let me also just return the variable y, and here you see that you get out set. Okay, so let's go on a bit to simplifications. So Jupyter Notebook does many simplifications just automatically. So for instance, if I try to write in 2x plus x minus 5 and run this cell, then I will get out 3x minus 5. The reason for this is that 2x plus x is 3x, and it does this simplification automatically. There are some simplification it will not do automatically. For example, if I write sp.sine to get the sine function, take in the symbol x, take the square of sine, and add sp.cosine of x, and take cosine also to the power 2, run this cell, then you will get out sine to the power 2 plus cosine to the power 2, even though sine squared plus cosine squared is identically equal 1. In lecture 5 on SymPy, we will learn how to simplify those kinds of expressions, but this is not something SymPy will do automatically. So we have seen that trigonometric simplification is not something SymPy do automatically. However, division is something it does. So for instance, if I take 2 times x divided by 6, run this cell, then it will automatically cancel the 2, so we end up with x divided by 3. Also, if you take x divided by x, you will end up with 1. So to summarize, addition, subtraction, multiplication, and division are usually simplified in SymPy. There are cases where it isn't. For example, if I take x times x plus 2, run this cell, and I forgot the multiplication symbol here, so let me run it again, then I end up with x times x plus 2, so the expression I started with. So SymPy will not expand out these parentheses without you explicitly asking for it. The reason for SymPy not carrying out this multiplication is that it might look better this way depending on what you want to do with it afterwards. But you can always actually make SymPy do the multiplication. So let me call this expression for exp like this and run this cell again. And let me also just print it out. So what we are going to learn now is how can we expand this expression. And the way to do it is to use the expand method. So here we can write exp.expand like this and run this cell. And now SymPy does the multiplication with x times x, which is x squared, plus x times 2, which is 2x. One thing you should note is that expand does not change the original expression. So if I write in this cell exp, I end up with the original expression. You can also use the expand method as a function. So you can write xp.expand exp like this, and this will also expand your expression. So often in SymPy, you will have the choice between using things as a method or using it as a function. So let's do another example with using the expand method. So first of all, I want to define 2 more symbols, and we have a special way to do it, or a shorthand way to do it, with using symbols. So this is used if you want to define several symbols at once. So in here, I need to have my variable names. So let me try to define s and t as variables, and I either need to separate them with a space or with a comma. So let me choose space here and run this cell. And what I end up with is a tuple here. So let's just check that it's indeed a tuple. With type sp.symbols. And you see that the type is indeed a tuple. This means that if I want the variables, I can use what is called tuple unpacking. So I can write s, t equal sp.symbols. And just to spice it up, let me use comma as the separator, like this. And now I can use the symbol s, or I can use the symbol t. So let us define a polynomial in s and t. And I want it to just be some factors multiplied with each other. So s plus 2 times t minus 3. And let me also give this out. And here we have the polynomial in 2 variables. So what I want to do now is to actually expand this expression. And we can do this with the expand method again. So I write poly.expand like this. And we see that this is the expression when we have expanded it. So this is one way. So you can expand expressions, and it would be very natural that you also could factor expressions or factor polynomials. So this is what we are going to do in the next section here. And we are going to do this with the factor method or the factor function. You can choose which of these you want to do. So let me define an expression in one variable. And let me just take x squared plus 2 times x minus 15. And let me just return it so you can see it. SymPy does not automatically factor expressions. So one thing I should admit is that I know that this expression has really nice roots because I did this computation beforehand and just multiplied it out. But let's say that we do not know what the roots of this is. And it's a second degree polynomial, so we know that it's possible to find the roots. So let me write xpr.factor and just use the factor method and see what happens. And then we ended up with x minus 3 as one factor and x plus 5 as the other factor. So here you have a really useful function if you want to factor things. The factor method will not always manage to factor your expression. If you recall from your math courses, we know that for 5th degree polynomials and above, there does not exist an explicit algorithm to find all the roots. So even though you end up with SymPy saying that there exists no answer or not giving you a factored expression, this does not mean that it doesn't exist any. Okay, so let's move on to the final example on using the factor method. So let's say that you want to write a lot of different symbols, let's say 10 symbols. This would be a lot of code, just writing x1, x2, and so on, all the way up to 10. Luckily, SymPy have a very short way of doing like x1, x2 up to x10, and this is also done with symbol function. So let me write xv for x vector, and this is going to be sp.symbols, and it takes in a string, as in the previous example, and I'm going to write x from 0 to 3, like this. And let me run this here, and let me also see what we get out. And what you see is that it starts on x0, and then it goes to x1, and then up to x2. So what this notation does is to create a lot of different symbols in a very short manner. So for instance, if I try to do 10, we end up with all the symbols from 0 to 9 here. So the last entry here is exclusive as usual with Python. I will not need all 10 symbols, so let me just do 3 here and compile it again. So let me write another expression, which I'm going to call x, and I'm going to take xv, take out the first symbol, which is x0 here, to the power 2 times xv, take out the first symbol, which is x1 here, times xv, take out the second symbol, which is x2 here. And then I'm just going to add xv of 0 times xv of 1 times xv of 2, like this. And let me also print it out here. So what you can see is that x0, x1, and x2 is a common factor in this part and in this part. So let me use the factor method as a function, sp.factor ex. And here I end up with my factored expression here. Okay, so I hope you liked this video. If you do so and want more information about SymPy, then don't forget to subscribe and like this video. And we will see you again in the next video for more SymPy.